In this video, we're actually going to take a brief departure from the regular plan of moving on to another method. Instead, we're going to take a look at the same method that we learned in the last video, substitution, and we're going to apply to a much harder question. This question comes from the COMC exam. I'm not fully sure what that stands for, but you can just search it up. And the question that we're asked is a system of equations, but instead of one variable, instead of two variables, we're given three variables. And not only are we given three variables, but we have to be a bit creative with how we use them. So the first equation is x plus 2y minus z equals 5. So that's the first one. The second one is x plus 2y square, whole square, minus z square is equal to 15. And I think our last equation is 3x plus 2y plus z equals 11. And they're asking us to find like x, y, and z, right? So they're asking us to solve for all of them, not just one of them, nothing like that. We need to find all of them. So how can we do this? Well, notice that just for a brief second, we can kind of look at x plus 2y as one entity, right? Like, I don't want to give it another name and make it more complicated, but just think for a second that x plus 2y is one thing. You're squaring that thing and subtracting another square. What's that? That's a difference of squares, right? How can you rewrite a difference of squares? So let's just take this down here. You can write this as the first term, so that will be x plus 2y, plus the second term, times the first term, x plus 2y, minus the second term. And then obviously, this is the same as this, so the right hand side will be the same as 15. The unique thing is we know x plus 2y minus z, right? How do we know that? Because it's given to us right here, right? It's another one here. This is equal to 5. We can divide both sides by 5. And we now find that x plus 2y plus z is equal to 3. Okay? Well, if we're given this, and we're given the fact that x plus 2y minus z equals, well, it is 5, right? We know that x plus 2y is the same in both of them. We can, okay, there are a few ways to go about doing this, right? There are a few different methods that we can use. I think the easiest one to use would just be to, I wanted to introduce this in the next video, but I think it's more useful to just do it now. We can subtract this entire second equation from the first equation. And in doing so, we'll see that, so I'll write out the whole thing for you. X plus 2y plus z minus this entire thing. So x plus 2y minus z. The reason we're subtracting it is because the x and the minus x will cancel out, the 2y and the minus 2y will cancel out, and we'll just be left with a few z's. Right? That's it. That's why we're doing it, because now we can solve for z. And if you want to think about it another way, imagine that, remember, we've still been dealing with x plus 2y as one entity. So even though it's three variables and two equations, which you don't know how to solve yet, x plus 2y is basically just one variable, right? And so that's why we can cancel it out. And we have to do the same thing to both sides. So it will be 3 minus 5. Okay, when we solve this, it will just be 2z equals negative 2. So z equals negative 1. Z equals negative 1. Perfect. If z equals negative 1, let's check that that actually does work. X plus 2y minus 1 equals 3, x plus 2y equals 4, okay? X plus 2y minus negative 1 equals 5, x plus 2y plus 1 equals 5, x plus 2y equals 4, they both match up. That actually tells us that x plus 2y equals 4. First of all, that's the first thing. And we know that, yeah, z seems to hold, at least for now. Let me clear up some space here. And let me actually write this. Okay, I'm going to go ahead and clean this line over here. You can look at the rest of the stuff on the bottom if you need, but I'm going to clean that up. And we know that z equals negative 1. So if z equals negative 1, we can just replace that with negative 1 over here. Okay, that's minus 1, so we can just kind of remove that and just clean up some space here. That's minus 1. We can add 1 to both sides, so that will remove that, and this will become a 12. Oh, okay. 3x plus 2y is 12. and x plus 2y, which we just found, is equal to 4. Okay. Again, we can subtract the second equation from the first equation. The reason we do that is because 2y minus 2y will cancel out to give you nothing. And when we do that, we'll get 3x plus 2y minus, in brackets, x plus 2y, that's just 2x, equals 12 minus 4, which is 8. So x is equal to 4. We already have z equals -1. What else is there to do now? Well, you can plug it in here. If x equals 4, y will have to equal 0, right? There's nothing else it can be. If x is 4, that means 2y equals 0, so y equals 0. Just like that, we're done. Remember, they're asking for x comma y comma z. They're asking for that ordered pair. So we can just write right over here. Make sure you get the order right. X is 4, y is 0, z is -1. So that's it. That's our final answer. And I hope you saw that even though it wasn't all strictly substitution, a question that seemed very hard, very daunting, we were able to solve it fairly quickly. The main idea again was just isolating, right? Using some substitution kind of. Actually, we didn't really use much substitution here. We mainly used a process called elimination, which I will show you in the next video. So I guess it's kind of out of order, but if you don't know elimination yet, think of this as more of a brain exercise for you, like more of a challenging question. And if you do know elimination, then I hope it helped you over here. And yeah, that's our final answer. If you want, you can plug this in to each of the 3 inertial equations. That I think I erased one of them. Yeah, this was like plus z equals 11, something like that. So you can go ahead and plug this in, and you'll see that it does work for each of them. And that's the solution to this question. So I hope you enjoyed. I hope you learned something new from this. And I'll see you in the next video. Thank you so much for watching. Bye.